So here is another question. So it is given that a system has two opposite charges, one positive and one negative, of magnitude 2.5 into 10 to the power minus 7 coulomb, located at points A defined by the coordinates 0, 0, minus 15 centimeter and B 0, 0, plus 15 centimeter respectively. Find the total charge of the system and the electric dipole moment of the system. Okay. So here first we have the three coordinate axes. Let's say this is the x-axis, this is the y-axis, and this is the z-axis. Okay, so this is the positive z-axis and this is the negative z-axis. So we have two charges of magnitude. The magnitude of the charge is equal to 2.5 into 10 to the power minus 7 coulomb. So the positive charge is located at point A. 0, 0 means x coordinate 0, y coordinate 0, z coordinate is this. Let's say this one. 0, 0, minus 15 centimeters at A. Okay, at this point. And then we have another charge which is located at here, B. 0, 0, plus 15 centimeters. Okay, this one. So here is the negative charge, here is the positive charge, magnitude of which is this. So this constitutes an electric dipole with separation distance 2a is equal to 15 plus 15, 30 centimeters. Okay, or 0.3 meters. The total charge of the system, as one is positive, one is negative, of equal magnitude, so they cancel out each other, and the net charge of the system, that is equal to 0 coulomb. Now the dipole moment, that will be equal to Q into 2a, that is equal to, not the net charge, the magnitude of either charge, which is equal to 2.5 into 10 to the power minus 7 into 2a, which is equal to 0.3, which is equal to 7.5 into 10 to the power minus 8 coulomb meter. So that is the dipole moment. Okay, so this is the thing. So here is another question on electric dipole. So it is given that an electric dipole of length 4 cm, when placed with its axis making an angle of 60 degree with a uniform electric field, experiences a torque of 4 root 3 Newton meter. We have to calculate the magnitude of the electric field and the potential energy of the dipole, and the dipole has charges of plus minus 8 nanocoulomb. Okay, so this is the situation. We have an electric field, the magnitude of which we want to determine, and another thing, we have a dipole minus 8 nanocoulomb and plus 8 nanocoulomb, making an angle of 60 degree in the direction of the electric field, the dipole axis. And the length of the dipole is 4 centimeters. Okay, this is the length of the dipole. So here the concept of torque of an electric dipole which is placed in a uniform electric field, that comes into play. So that is given by Pe sin theta, where P is the dipole moment, which is given by Q into 2a, magnitude of either charge and the separation. Okay, so from this we can calculate the value of E, which is equal to tau by P sin theta, which is equal to tau by Q into 2a sin theta. Okay, so it means the value of the electric field, that is equal to the torque, which is given this much, okay, 4√3 Newton meter. It is given the dipole moment Q into 2a, that is magnitude of either charge 8 into 10 to the power 9 coulomb, separation distance of 4 into 10 to the power minus 2 meter, and sine 60 degree. Okay, so the value which is coming, the magnitude of the electric field, that is coming around 2.5 into 10 to the power 10 Newton per coulomb or volt per meter. So this is the electric field, the value of the electric field. The next thing which you have to do is to find the potential energy. So the formula, always remember the formula. So the formula for potential energy of a dipole, that is equal to minus P E cos theta. So again, minus Q into 2a, that is 8 into 10 to the power minus 9 into 4 into 10 to the power minus 2 into 2.5 into 10 to the power 10 into cos 60 degree. Okay, so it is coming around minus 4 joules. Okay, so this is the potential energy of the dipole. So this is the second part, and this here is the first part. Okay, both we have calculated. Okay.